Good morning, everyone, and welcome to this Copernicus Marine Service workshop. Today, we're gonna have a workshop on assessing ecosystem health with Copernicus marine data. To start, I would like to introduce you to some guidelines for today's and tomorrow's session. This session will be held on Zoom platform. It's a webinar format. And for the questions, if you have any questions, which we hope you will have many, we are using Slido. We will share the link to Slido in a few minutes on the chat. So you can post your questions and don't hesitate to ask your questions. Here is the code for the Slido session. You can also enter the Slido with this code, as you see on screen. And for small talk, you can also use our chat here on Zoom. Some other information about this workshop. You will be able to access resources we are providing you, as like the tutorials we will explore tomorrow in tomorrow's session, and also a participant manual, which give you the instructions, basic instructions to follow this workshop. You will find it on the Padlet. It's also a platform where you can find resources for each workshop. We will also share the link to the Padlet in a few minutes. There you will also find the replays of the sessions. So if you cannot stay for the whole sessions, it's not a problem. You will be able to follow it later on. And it is basically your notebook of this workshop. So without any further delays, I will introduce you to the agenda that we will have for today. I didn't introduce myself. My name is Andrea Carvalho from Mercator Ocean International, and I'll be your host for today. And I will also start this session by introducing you to the Copernicus Marine Service. After my presentation, you will have Razvan Mateescu. He will introduce you to the Copernicus Marine Service products. He will go through an overview of the products you are able to find in our service. After, we will have Anaïs Perrin. She will do a demonstration of MyOcean Viewer. And after, we will have two very interesting use cases on how you can use the data we provide on your research, on your work, and all related to assessing the ecosystem state. And so we will have Andrea Orihuela Garcia from the Barcelona Supercomputing Center and Luc Vandenbuckle from SC Jailoo SRL. And to finish today's session, we will have Cedric Giordan, who will tell us about the user corner of the Copernicus Marine Service, how you can access the data, how you can get in contact with the user support, and all the material, the learning material you can find on our website. Okay, and now to start our round of presentations, I will just give you an introduction of the Copernicus Marine Service. So if you are new here, if you haven't heard about the Copernicus or the Copernicus Marine Service, just to give you an introduction, the Copernicus is the European Union's Earth observation program. It focuses on 6 different services. And the goal is to investigate these different environments for a deeper understanding of the Earth, of the planet, and to improve people's quality of lives. So these 6 services are atmosphere, marine, land, climate change, emergency, and security. And today we're going to talk a little bit more about the Copernicus Marine Service, which focuses on the research and monitoring of the marine environment. So how can you access the service? Through our website, marine.copernicus.eu. You will, in our website, you will find an extensive catalog of products. nearly 300 products you will access, as well as ocean monitoring indicators. You will find it in one single format, so that it is easy for you to download it and use it. And the singularity of the Copernicus and all the Copernicus services is that the data is free, open source, and free of charge, and accessible to everyone in the world. So specifically, the Copernicus Marine Service provides data on three main axes of the ocean, or how we chose to divide it, on what we call the blue ocean. So more physical parameters like the temperature, currents, waves, sea height, etc. On the white ocean, what we call the ice coverage and everything related to ice. And the green ocean, which we're going to maybe focus a bit more today. So everything related to chemicals, primary production, chlorophyll, phytoplankton, nutrients, organic matter, and all that stuff. In terms of the offer you can find on the portfolio and the temporal and geographical coverage, and the nature of the data, we provide model data, in situ, and satellite data. The temporal coverage ranges from yearly, from daily, hourly, and also we provide a forecast, so a 10-day forecast. And in terms of the geographical coverage, it covers not only the global ocean, but also six main regions in the Europe basins and seas. Besides the products you can download, the actual data you can have access to, we also provide yearly extensive report on the state of the ocean, which you can also access for free. It's called the Ocean State Report. And to make it even more accessible, we also create a summary of this report to be more accessible to other communities, such as policymakers or just someone in a known scientific realm. As I said, you can also access ocean monitoring indicators, so trends and maps that give you an idea of a long-term. For example, we cover the last 30 years of data in several variables, and yes, you can also access that on our website. And so the Copernicus Marine Service tries to respond to several axes. Not only the environment component, but also the societal needs and economical needs. So here we have, for example, a representation of our blue markets, what we try to cover. And as we provide free and open data, we also we are also responsible to provide training on how to access this data and how to use it, how you can use it in your daily lives, in your research. And so we provide workshops like this one today, but also we have very strong user support that you can always contact with any of your questions related to the data, to the products. And we try to also create workshops and hackathons, so events that will build your skills. Thank you very much for your attention now. And now I will give the floor to our next speaker, who's going to tell you about, more specifically about the products you can find in our portal. Razvan Mateescu, the floor is yours. And so if you have any questions related to just everyone, if you have any questions, don't forget that Slido is the place to post your questions, even like the questions, more general questions. Just go ahead. Hi, Razvan. Welcome.
Hello.
Hi. So the floor is yours when you want to share your screen.
Thank you. Now I'm sharing. I'll present Copernicus Marine Environmental Monitoring Service product overview. You already start, so I will pass very fast on some slides. Accessing the web page of, actually it's a web portal of CMAMS, you can find a lot of panels and web friendly page because it's a service oriented to users, so it's it's always user friendly service. So you have also a user corner with a lot of resources, but also you can access through this portal specific services and specific data. I'll talk about these ocean products, several words about ocean monitoring indicators, and also about ocean visualization tools. You'll learn tomorrow and later afternoon, because these visual tools are very important to allow you to match and interact with ocean data across a lot of parameters you are interested in. So we have three main components in Marine Copernicus service portfolio. So we have data in Earth observation domain. So we have satellite observation data, but also in-situ observation data and model data. About satellite observation data, we shall discuss a few slides today. And on this domain, you may find in the CMAMS data portal L3 and L4, so products related to daily composite products for single or multi-use sensors in a track way or in a gridded product. Also, level 4 interpolation. You may find the daily interpolated and the weekly and monthly composites data. And sure that for in-situ observation, you'll find a lot of data from different platforms and different networks in the field, starting with Argo floats, buoys, surface mooring instruments, or gliders, data providing from different research expedition, from research vessel or ferry boxes, but also tide gauge systems, data coming from sea level recorders networks around the coast also. In the domain of model data, so for model data, you'll find the 3D numerical representation of the ocean with assimilation of real data in various algorithms and various for specific seas. And sure that this portfolio have a geographical coverage for European seas, starting from global ocean to Arctic Sea, Baltic, Northwestern region, but also Iberia, Biscay and Irish area, also Mediterranean Sea, and also Black Sea. Black Sea as a terminal sea, it's also included in the European Sea. For all of this data can be accessed on a temporal coverage, starting from real-time data with daily or hourly quarter resolution, but also to up to 30 years of data. Sure that you have forecasts from 1 day to up to 10 days sometimes. And for this regional and global coverage, there are specific products like temperature, salinity, and these are most important parameters you'll find here. Currents, sea currents, chlorophyll, ice, and sure waves in your area of interest, including coastal and open sea. we talk about the free available of free availability of this data, and in 4D view, you can see the interesting dynamics and the amazing features of this data. And from this picture, you can have an idea of the works involved in all these services. So the magnitude of the efforts. In Copernicus Marine Service, you'll find the specific sea status parameters or indicators in 3 randoms. So we have physical state parameters for blue ocean, biological parameters for green ocean, and also white ocean in relation with ice cover parameters and indicators specific for these northern areas. About blue ocean, we have for temperature and salinity specific parameters for bottom temperature, salinity, or sea surface density, or data for mixed layer depth. For hydrodynamics, you can have velocity for geostrophic and barotropic types. Also, Stokes drift in specific propagation studies, let's say in oil spill studies. And also, you can have tidal velocities and vertical velocity for studies involving mixing areas. About sea surface elevation, sea surface heights, you can have heights above geoid or sea level, but it may have also mean dynamic topography for large-scale current distribution studies. And also for waves, you may have significant wave heights, but also mean wave period and directions, also stock drifts. And sure that you have data for specific waves like wind waves or swell waves. For wind, you can have wind speed and direction, but also stress for a study of sea atmosphere interface. All these data and parameters involved in all 3 domains of model, satellite, or in situ data. You can have a spatial resolution for all of these. You can have a spatial resolution from 2 kilometers to 25, but also temporal resolution of hourly, daily, or monthly means, together with some forecast, starting from everyday forecast to up to 10 days forecast. So all these for a time series of years, so almost 30 years. All these daily updated. Blue ocean, related to blue ocean. So we talk about these physical parameters. This ocean described by physical parameters or marine hydrological parameters. For this, for the global ocean, the most important if you want to see things at global scale. So we have here several top products. In the model, for the model data, you may find in the data portal, so global ocean, physics analysis and forecast daily updated. From 2019 up to present, and this data, grid data, you are plotted with very skilled model assimilation scheme. Also for satellite data, you'll find the global ocean sea surface temperature and sea ice analysis data since 2007. But the level of processing at level of processing of interpolation, so L4 products. And here for in situ data, you will find since 2010 a lot of observation at the level of pre-processing. So you find the data which you may process in your specific domain and your area of interest. About green ocean, the most important for ecological marine ecology and for ecology studies in marine or coastal areas, you may find data for model satellite in situ data. So for primary production, you'll find chlorophyll A, primary production of phytoplankton types, and also for low and mid trophic level, you may find data on zooplankton distribution or micronecton as well, together with dissolved oxygen on water column, and also for transparency and turbidity, you can have parameters on reflectance, on absorption coefficients, and also backscattering coefficient, also light attenuation, Secchi depth, but also data for suspended matters and turbidity. In carbonate systems, you have data for pH and also alkalinity, data about CO2 parameters, but also dissolved inorganic carbon. And for nutrients, nitrate, phosphate, silicate, and iron, and ammonium as well. All this for a resolution of 20 kilometers to 100, sure, for daily, hourly, or monthly means. But also we have forecast for every day up to 10 days also for past time series of 30 years. All these sure are daily updated. So for green ocean, top products you may find for global ocean, the global ocean chemistry analysis and forecasts with resolution of 0.25 degree times 0.25 degree with model assimilation and data starting from 2019. For satellite observation, you'll find global ocean color for biogeochemical level 2 products since 2022 with a resolution of 4 kilometers and level of observation in L3, so interpolation, data interpolated. And also for in situ data for global ocean, you'll find several biogeochemical products since 1990 up to 2021. So here that are in the level of pre-processing, and you can process as you like. For white ocean, we have model and satellite data. In situ data are a little bit difficult to be maintained in this area. So here only expeditionary area, as you already probably you can imagine this. Why? So we have here ice concentration, ice velocities, ice thickness. All these sea parameters in relation with ice surface temperature with a resolution of starting from 2 to 25 kilometers with hourly, daily, monthly temporal coverage, and also forecast up to 10 days and other time series up to 30 years. Sure that here data are daily updated, and all activities related to blue economy are based on this data in a harsh environment. So this ocean, white ocean, and several top products you may find in Siemens data portal, several forecast data with a resolution of 3 kilometers, model assimilation since 2019, but also model data with reanalysis and forecast since 2019 with a larger resolution of 12.5 kilometers, but also with data assimilation. For satellite data, you may find global ocean in Arctic and also Antarctic seas, the ice concentration, age, and the type of and drift of these icebergs. Since 2019, with a resolution of 10 kilometers at the most processed level of a product. Related marine satellite products. So we talk about Earth observation. Here, the provider, it's European Space Agency, and you know that on European space there are several satellites, and for ocean color we have this Copernicus Sentinel-3, which is a Sentinel launch in 2016 for ocean and land color. So this instrument for ocean and land color have a global coverage and also for coverage for all European seas, with a special resolution of 300 meters, grading latitude and longitude system, and temporal resolution of daily, monthly, or also interpolation of daily depth field parameters. As a parameters, you may find here the satellite provides remote sensor reflectance, chlorophyll concentration, transparency properties of the water, including total suspended matter concentration. But also you'll find inherent optical properties of the water, so absorption and backscattering, but also photosynthetic active radiation and aerosol optical thickness, and sure that the aerosol above water surface. So the data provided by this sensor can provide and can be assembled in a thematic center, in the thematic data assembly center of ocean color. As you know, there are 8 thematic centers for Earth observation, and for ocean color is this OCTAC, providing chlorophyll, optics, but also provide operationally 2 levels of processing. So we talk about this daily composite and interpolated products, and sure the resolution involved and mentioned. So for all these 6 domains of data, there are regional products produced using a regional algorithm. Regional algorithm and local algorithm involved here are very important to improve the quality of Earth observation data. So for all these seas, there were quality check and dedicated validation analysis based on a lot of works developed on the sea, a lot of expedition taking parameters, and a lot of sensors spread and in all this European Sea and spread, and also maintain to provide daily data. So for all this, we have specific data and reliable data in the Earth observation domain. For high-resolution coastal products, there is another sensor, which is provided by Sentinel-2, covering coastal strips of 20 kilometers for all European seas. The sensor cover a spatial resolution of 10 to 100 meters. Grading is in latitude and longitude system. And also for temporal resolution, provides daily, monthly, and daily depth field data. As a parameters, you'll find also remote sensing reflectance, turbidity, suspended particle matter, but also particulate backscatter and chlorophyll concentration. Based on this sensor, you can have also this is the coverage of the sensor in specific areas. And sure, if you are interested in a specific sea, I give here example of the Black Sea. For all for domain, you can cover here in a temperate region. We don't have data for green ocean, so it's not encompassed here. White ocean, only data for blue ocean and green ocean parameter states. So for Black Sea, for example, we have temperature, salinity, currents, wave, and sea surface elevation. Also for ecological studies, all series of parameters and indicators, and also forecast related to all of this. And based on what you can make various studies based on this data. For in situ products, on the portal of CMAMS, you'll find up to 15,000 data sets provided by different platforms installed in the sea. And for this sea, with the poorest data provided, so for the Black Sea, because here it's the network of data in situ, it's in the process of developing, in the process of development. So here, for example, you may find only few sensors providing data, but having these facilities, you can select your level of interest of time series, level of time which you are interested in. And here we have an example of wave data provided by a spotter buoy. Means GPS buoy providing wave parameters in specific area. Here we have Western Black Sea coast data in with facility of specific wave parameters provided. And here we have wave significant height, wave period, peak and wave, all wave parameters of interest, but also data about sea surface temperature. So these buoys have also sensors for specific parameters. In this, talking about Black Sea, there are a regional project founded by ESA, European Space Agency, or CMAMS. And for this project, for SIPS, called Earth Observation for Science and Innovation in the Black Sea, European consortium was focused to develop and to make better refinement of the satellite or in situ data, and better in order to obtain better products for ocean color altimetry and especially salinity, because here, as you know, there is a strong input of Danube River and salinity. It's quite important factor of marine dynamics. Based on this, there are several science cases related to river plume tracking, ocean health indicators, and coastal state at different scales, especially mesoscales, together with the oxygenation process in this terminal sea were developed. And all these data you may find on the project data and web page. I'm sure that you will enjoy surveying this data related to this AO4 SIPS project. In the domain for the model products, for all these European Sea, there are 7 modeling forecast center providing data for all European seas. And here model are related to physical, but also biochemical variable of ocean dynamics. So Siemens data products, if you will make a survey on the web portal, you'll find over 275 ocean data products related to blue ocean, white ocean, and green ocean, but also numerical data coming from numerical models up to 93, with in situ observation, but also satellite observation instead. For example, for Black Sea, when you select a specific sea, you will find the numbers and products available on Copernicus Marine data portal. In the data in the web page of Copernicus Marine, you will find also specific indicators, and sure that here a series of key variables for monitoring of the oceanic trends in line with climate change or other products more or less stressed in these times. And all these data set sure that are free downloadable at a resolution of 29 years. So going to this web page, you may select the region of your interest, and here you will find ocean circulation, ocean climate, ocean availability on the extremes, but also ocean health monitoring indicators. And based on this, you may develop your ecological studies in your specific area of interest. As an example, let's say also Black Sea, you might have here some specific ocean health indicators, not very well developed, but you'll find the chlorophyll and primary production indicators together with ocean deoxygenation indicators. So here the icons looks like these ones, and sure that all these trends and time series for observation and observation reprocessing you will find in a specific format for downloading. And for this downloading tools. It's a very easy access also in automatic way, but you can have this manually and sure that all these indicators are very easily accessed on this web portal, web data portal. About blue ocean monitoring indicators, we have first of all ocean heat content, and based on this, you can have an image of variation during times, and sure that all your climate change study will benefit from this data support, and this indicator will clarify all your interest in all your concern in your specific area. About green ocean monitoring indicator, we have first of all ocean acidification in relation with pH trends, and also specific data for as a time series provided by also by observation, but also by model data. So starting with your interest in the marine data and services to meet your marine ecology or ecosystem challenges, you may have a lot of you may have a series of parameters of interest describing your ecological state of the sea, and also you may select specific data from a model, from satellite or in situ data. All these, say for your specific interest and your specific sea. If you don't have in Siemens specific indicator related to your interests, in case of eutrophication, I give this example of Black Sea again, because this ecological indicator of eutrophication is not provided by Siemens at the moment, but you can have a study and an approach for this derived Siemens data parameters, and also satellite remote sensing data and numerical model together with in situ data. You will help you to determine the spatial component of marine biological process in the surface layer. Also, for this eutrophication study, you may select data from model and from Earth observation also. And based on this, you can approach the criteria related to descriptor 5 of Marine Strategy Directive. And also you can approach specific tools, assessment tools in your area. We can mention here for Adriatics and for Baltics, two of these eutrophication assessment tools. Also in Black Sea was started to have such assessment tools, but for this one, you always to have a summary of the monitoring and forecasting data together with ocean thematic ocean products, ocean color products to supervise your approach in this regional study. For this as a use case, you may find in Siemens also in the Black Sea a project founded by Siemens at the level of 2019 and 2020, a project called Skyfish for And the Skyfish is a project for support of fishery and aquaculture in this Western Black Sea area, based on several sustainability indexes. So this is a specific services concerning the area of, let's say, big fish productivity. And you may find here a series of water parameters, but also several indexes, as I mentioned. For all marine and ocean indicators, you will find in Siemens product documentation. First of all, it's a product user manual encompassing certain explanation on the constituent data sets, but also explanation on the files name and format, product update schedule, and also the availability of the data, together with certain quality information documents, also for information on accuracy, validations, and also quality change in various variants of this data set. Summarizing, we can say that marine Copernicus services in a domain of Earth observation data are quality control and flag, and their quality and coverage varies in space and times for all European seas. As I mentioned, with the specific algorithm approach for these areas. Also, marine Copernicus service models and forecast are in the process of continuous refinement in terms of resolution, spatial resolution, but also reprocessing studies and data sets. And always these models are involving observations and data simulations schemes. Sure that these model forecasts are evolving, as I said, and due to this continuous overpassing of intrinsic errors of the models and the quality of the model products in space and times are in relation always with in situ data involved and assimilated, but also with Earth observation assimilated in their process. So a set of standardized metric is used to estimate its quality. This validation process is continuous and is carried out on the daily to weekly basis. The product quality dashboard include also several estimation accuracy numbers and forecast score, which are regularly updated, and also plant evolutions are encompassing filling the gaps and adding new products with better quality, also better quality information on missing parameters on indicators for all European Sea, including Black Sea, improving the user experience and starting to display the product informations in with better visualization tools. Okay, so we will find better information in these sources. And thank you for your attention. If you have a question, yes.
Thank you, Razvan. Thank you for your presentation. I hope this gave you all a good overview of what the Copernicus Marine Service provides in terms of data and products. Now we have a few questions for you, Razvan, if it's okay.
Yes.
Just before we go to the questions, I just want to remind everyone that a certificate will be provided at the end of this workshop. So tomorrow, after the second session. Also, you on the Padlet, you can access the resources, the replays. So if you cannot follow today's and tomorrow's session, it's not a problem. And besides that, you have posted many questions on Slido, which is great. However, we're not going to be able to answer them all live, but we will also make a document available on the Padlet with all the answers, or as many questions we can answer. Thank you once again for all your questions. And now, Julia, yeah, if we can see what sort of questions you've asked and how Razvan and I, myself, we can help you. So the first one, I may not be able to then, oh, okay, so it's one of questions. So yes, no worries, the replays will be made available not only on the Padlet, but also on our YouTube channel later on. First one, so is it possible to get blue ocean data for a specific location if you have the coordinates?
Yes,
One,
sure.
yeah,
There are a specific tool for this, and also in CMAM's web portal, you will find also webinars for this data gathering, but also you'll find this if you want to do this manually, but also if you can, if you use a informatician working with Python products and Python specific instruments like this automatic getting data. You'll find this today and tomorrow about visualization viewer, specific viewer, when you can point your area with the coordinates you have it, and based on this you can have a plot on data on that specific location with your coordinates, and also several automatic services can be approached also.
Yeah, exactly. So Anaïs will also show you a little bit more in a few minutes how to visualize the data.
Yes.
And tomorrow, like Razvan said, we will have the practical session. We'll really show you how to access the data, import it into Python, for example, and QGIS, and then how to do to analyze your data. So next question, what about yes, I work on a yes. So I work on a project on climate resilience by coastal biota. What sort of data can I access from Copernicus for South Asia and northern US region?
Yes, we talk about global ocean data, and for this green ocean, you will find a series of data in your area of interest here, South Asia or Northern Asia. Just go on the web portal, and here will be easier to make a path of. So we'll find just. This is a condition to go on the web page on the using the tools, and you'll find the data in the area of interest.
Yes, exactly. I agree. So another question, what about an API to access the data? So online, maybe I can answer that one. On our website, you will also have access to the help center. And over there, you will have many articles already written by our user support team, and which explain in depth, like how to obtain an API, how to access the data specifically. So we can maybe share with you on the chat the link to this particular article explaining the API. So yeah. I'll try to do that as we speak.
About plastics and plastic pollution, microplastics.
Yeah, the
I
next
think
question.
this matter is an ongoing process of development. But you can approach studies of coastal drifts. So you may approach the physics of physics here, and according with current distribution in your area, you can have some patterns related to plastic or microplastic pollution.
Exactly.
So
Yeah,
yes,
indeed, we do have some maybe use case that you can find online, and also some
yes, some
data.
particle tracking modules
Exactly.
should be attached in the future for this physics.
Exactly.
These hydrodynamics models, and these are in ongoing process.
Maybe we have time for one more question. Can blue ocean data and green ocean data over a specified time window be extracted into a spreadsheet like Excel for further statistical processing? If you have any experience with that.
For this data extraction, you will find on the data portal only a format of netcdf, and if you want to use, let's say, Panoply, you can extract this data on your specific area in a spreadsheet format, like Excel. So you can export in Excel after this Panoply software usage.
Mm-hmm. Thank you.
So and it will be an exercise tomorrow or today. It helps.
I'm not sure if specifically on a spreadsheet, but for sure how to extract the data. Yes, and yeah, how to visualize it on Python and yeah, QGIS. So maybe we now pass on to our next speaker. Thank you very much, Razvan. Now I'll give the floor to Anaïs Perrin, and she will introduce you to MyOcean Viewer. So this is a tool to visualize Copernicus marine data. The floor is yours, Anaïs, whenever you want.
Yeah. Hi, everyone. I'm Anaïs from the user support team of Copernicus Marine. I will introduce you the main feature of the MyOcean Viewer Pro. So to access it, you just have to click on Access Data here. And here you have our three different, and on the ocean visualization here. And so here you have our three different ocean visualization, the MyOcean Learn, the MyOcean Lite, and the MyOcean Pro. And today I will present you the MyOcean Pro. So here you have two layers will open by default on your interface. By passing your mouse over the name of the variable, you have access of the open product as well as the dataset and the variable. These two layers come from two global forecast products. The first is for physical data, here the temperature, and the second for biological data, here the global A. In this presentation, I will focus on the biological dataset from the Mediterranean Sea, looking at the nutrient inputs from rivers. So to search for a product through our catalog, you just have to click on Add Layer here, and you arrived on our Copernicus Marine data store, where near 300 products are present. We therefore have all our projects classified according to different categories. The most popular, the project recently opened on the MyOcean, new in Copernicus Marine, and so on. Here you will notice an homogenization of the thumbnails of the different products in the catalog. Physical data have a specific palette here and here, as do biological data, sea level, and so on. For base map, near real-time projects are in dark, and the multi-year product or light in situ product have a bathymetric base map. A reminder of data acquisition mode is visible in the upper left-hand corner of the surname, representing a model, satellite observation, and in situ. The short description of the product informs us about the name of the product, the data assimilation mode used, the resolution about the temporal coverage, or the variable present in it. The filters column on the left allows you to refine your search, either by entering keywords or by informing time period, or clicking directly on the parameters corresponding to your search. In this version of the MyOcean viewer also lets you enter the depth at which you want data. Here we are going to search for nutrient data, so I will click on nutrient and search for Mediterranean product here. So here we can choose between a near real-time product with the dark base map and a multi-year product with the white base map. I will choose the project with the most recent data, the first. So you arrived on the description page of the project, which is a presentation and the references used, and a part on the parameters taken account for this one, like the source, the temporal extent and resolution, and so on. You also have different tabs. Here you have the notification types that tracks all the incidents, improvements, and maintenances in progress or past on the project. The data access tab shows you all the datasets containing in the project, as well as direct links to the Motu interface, OpenDAP, FTP, browse files, and WMS links. By clicking on the small information button, you arrived on the articles of our App Center by linking with the chosen access mode. These articles are there to explain you how these download modes work. Here is an example of our article on the advantage of Motu download service. The contact tab allows you to contact the Help Center, and you have a documentation section with the links to the user manual, the quality information document, the license, and our article on how to cite our projects in your publication. So the user manual document contains all the technical information relating to the project. The quality information documents provides information on all the more scientific information or information relating to the mode of data acquisition. If you like the project, you can share it using the share icon here on the top right. And this button allows you to copy the URL address of the project. So to visualize the variables of the project, you just have to click on Add to Map, and you can thus choose variables of interest present in different datasets in the project. Let's choose some data from the daily dataset. The distinction is made in the name. Here the D for daily and the M for monthly. So let's take nitrate and phosphate data. So I will click on the Add to Map here and here. You will notice that only datasets relating to our nutrient filters are visible. To view other datasets, you can click on All Layer. This version of MyOcean Viewer Pro now allows you to display the bathymetric data here. So let's take a look at the seabed depth layer here. Oh, okay. So on the MyOcean, you can easily pan around the map holding down the left click, and you can zoom in and zoom out with the mouse wheel. For more visibility, you can change the order of the layer by dragging them up or down. And you can choose to hide a layer or not by clicking on the eye. I will close the last two layer here. All right, so we have the phosphate, the nitrate, and the seabed. Let the seabed down. You see here that 5 icons are present. The first is for download data. The second return the description page of the project. The layer icon allows you to change the open variable by another present in the dataset. The gear is used to customize the layer. And finally, you have the log icon. This option is not available for all the variables in our catalog, but this is for our datasets. So I will start by changing the color scale here for more visibility. I can also modify the opacity of the layer, the minimum and the maximum values of our gradient, and choose whether or not to hide the out of bounds values. So here we also change the color palette for the nitrates. So here we already see an increase of nutrient concentration at the river mouth, such as the Rhone and Po rivers. This apply both phosphate and nitrate concentration. These nutrients are essential for underwater life and growth of algae. If we look at the bathymetry at this river mouth here, thanks to the seafloor depth dataset, we see that there are continental shelves at this level, notably the Gulf of Lion Plateau and a larger part of Adriatic Sea on the continental shelf. If I click on the map, I make a point appear, give me the coordinates as well as the values of different open variables. You will note that the depth data is not displayed with the graph, nor can it be downloaded with Motu. This is static data and must be downloaded via FTP or with the browse file option. The latest version of MyOcean, however, allows you to use them. If we look at another variable here, you will see that a bar appear on the bottom of our screen. This is a time range. This bar is not displayed with static layer because this data is not changed over the time. The thicker line indicates the variable as a variable data time range on the open dataset. By zooming a little further on this bar, we see that we can even choose to display the data at a specific time. But since it's daily data, it will not change with hours, but with days. The right and left arrow on your keyboard allows you to change the date displayed here day by day. To get an overview on this hour by hour change, we will open an hourly dataset. So we will try to displaying hourly temperature data. To open another variable layer, you can easier replace a layer already open by another layer present in the same project using the layer icon. Here we won't find any temperature data, so you can also click on add layer and search for project. You see that the previously filters used is still enabled. We can easier modify them or remove the filter. So I will remove the filter with the cross. So I want the temperature data in the Mediterranean Sea, and I want hourly data in numerical model. So the first project is a forecast model, and the second multi-year project. I will choose the first, and I can access the variable directly by clicking on the Add to Map here, and choosing my variable from the hourly dataset here, H for hourly here. And here my temperature layer displayed. For greater visibility, I will change the color of my data here, and I will modify the minimum and maximum values here. All right. Oh. All right. With this data set, the right and left arrow display data hour by hour because it's a hourly data set. And you can clearly see, the increase of the temperature during the summer period, and the shallower depths combined with the summer temperature variation and nutrient input are favorable factors for algae growth and development. This explains the proliferation of Ostreopsis ovata in the Abruzzo region and the Colerpa rasmusa in the Gulf of Lion. It's two species of algae. You will notice another option, the depth level on the right here. It's possible to, because it's a three-dimension layer, by default the data display are surface data, but you can change this parameter by clicking directly on the scale or using the up and down arrow on your keyboard. The depth level display here change every 100 meters. I will stay on the surface. Above the scale, you have different objects that can be created, a point as seen previously here. the line for the creation of a transect, like this, and an area, like this. Object creation is useful for visualizing graphs based on your open variable, but also for downloading this particular data. You also have the settings here, where you can, for example, log out. You can also change the base map color here, the projection and the units of your object and more. So let's then return to our object. We see that graphics have appeared. This is a representation of a sample of data for this location. You can delete graphs here or make other appear again, depending on the variable open on your HFS. Here, you can also choose to download this data in CSV format, but to do so, you must enter your Siemens credential. As a reminder, the registration is completely free. You will be asked for your credential each time you want to download data if you are not already connected. So I can try, I can log in by trying to download a sample of data in CSV format here in the settings, or by clicking the download icon here. Note that the download of this data in CSV format is does that it reflects all the data in this object is just a sample, even if you increase the resolution of your graph here. So let's move on the download part. Here, when you click on the download icon, so here we need to fill the geographical area we need. You can either manually enter your coordinates or using the define on map option. This option, with this option, we can draw our area of interest directly on the map by maintaining the left click. Here, you can also erase your selection with the cross, or even select a previously object created object. The date range section, in the date range section, you must fill in the time period you are interested in. Next to it, it indicates the time period available for this variable in this project. Be sure to indicate dates includes in this one. The same way for the elevation range here. And you can also use the as in map option, like the define on map option. For example, here, the date is the date of my visualization. For elevation range, you can choose the level you are interested in, and you can also use as in map option. For example, here. Voilà. Dataset contains, for the dataset contains several variables, you have an additional option called also download, which allows you to download several variables containing in the dataset in the same time. Here it's the phosphate, and I will also choose to download the nitrate. And the final step is to upload your parameterized data here. Word of caution though, downloading via Motu is subject to 1 GB data download limit. This request, if your request exceeds this limit, like this, for example, like this, a red message appear in red. The links takes you to the dataset tabs from where, by clicking on the information icon, you have access to the article of our epicenter I seen previously. Don't hesitate to take a look at our epicenter. We have also an article on how to download data that exceeds this limit. So next to the download button, you have the API request button, which allows you to obtain the request that corresponds to your parameterized data. This request is useful when you want to download your data programmatically, for example, with Python, for example. The new version of the MyOcean viewer allows you to download with another option, browse files. It's concerned the acquisition of the native files and therefore not a subsetter. All you have to do is browse the directory and select directly the download files you want to have here. In case of problem, you can contact the Help Center by clicking on the small bubble at the top, talk to an expert. If you have a problem, in particular a download problem, it's important to communicate to us your API request to us so that we can help you as best as we can. To do this, I will open a chat section here, and I will copy and paste it into my message. You will also notice that on the home tab of the chat, you have direct access to our articles present on our epicenter. You can search for an article by entering keywords such as MyOcean, for example, here. And you have an article, by the way, that tell you how to view data on MyOcean Pro, like in this presentation. And you will notice that at the end of this article, you have a question and answer section that we regularly update with the most asked question about the MyOcean viewer. The MyOcean also have a sharing functionality. By clicking on the icon here, you can then share your visualization with whoever you want. You can also create an image or a video and even an embedded link to include your visualization on your website, for example. Finally, you have the information icon here, which details all the keyboard search shortcuts we can use on the MyOcean. Don't forget that we have some articles available on our epicenter concerning the MyOcean viewer, but not only. The user support team is nevertheless here to answer your question and to help you if you encounter difficulties. Thank you.
Thank you very much, Anaïs. That was a really nice presentation, and I hope it gave you all a nice overview of how to access the viewer, how to visualize the data, and the possibilities you have on the viewer. So now we have a few questions for you. Slide you. Thank you everyone for all your questions. I will remind you that the questions we're not able to answer here live, they're going to be made available on the Padlet with the respective answers. Okay, first question for you, Anaïs. May you recommend an okay, maybe this one is not so much for you, but application. May you recommend an application tool to visualize the current and sea temperature data? The viewer?
So you
Favorite
can use the MyOcean viewer, but you also can display your data on QGIS. For example, we also have some article on how to display the current on Python, for example. So I encourage you to go to our App Center, but the MyOcean viewer is created for view our article, visualizing our data, sorry. So it's a great tools, but you also have a full or other option.
Yes, they still remain open source. That's good. So another one, is there any way okay, so this one I saw it is maybe more for someone from the Situ thematic center. We got this question: is there a way citizens or academic institutions, for example universities, can be involved in situ data collection, or is it only restricted to the CMEMS community? I don't know if we have Fernando Manzano here with us today. He's a representative from the thematic center. If you're there, Fernando, that'll be cool to have your input on this question. If not, I have to admit, I am not sure if there is still, there is already this possibility for other institutions or even citizens to upload their data. I think it remains still restrictive. But well, we can wait if Fernando pops in later on, but we can pass on to the next question then.
Excuse me.
Oh yeah, you're there.
Andrea, yeah, I was working at the same time. I'm sorry, but could you repeat me the question, because I was not paying attention. I'm very sorry. Sorry.
Don't worry. Thank you for coming.
Yes.
So the question is there any way citizens or academic institutions, for example, universities, to be involved in situ data collection, or is it only restricted to the CMEMS thematic centers community?
I don't understand exactly, but I don't know if the question is about contributing to provide data.
Yes, I understand it like that.
If that's the case, of course, we are completely open to ingest more and more data. So we are fully interested in everything. So it's detected any data that it's not already in the CMEMS, in Copernicus Marine Service, then for sure you have to contact us. You can contact the regional responsibles, or you can contact me directly, or the Institute tag or whatever. Yeah, and we are going to manage it. So for sure, we are completely interested in getting more data.
But so it is not yet. So the platform, the Institute platform, is not yet open for people to upload the data directly, right? As far as I understand. It's fully operated by, of course.
Yeah. That's the case.
But so if anyone is collecting data, or I mean, for your research, if you have data, you can then contact directly the Institute thematic center.
Yes, we organize in the region, so probably depending on where this data come from, then one region would be in charge of that.
Yeah.
And then we use the APIs provided or whatever in order to ingest all this data. Yeah, but
great.
Yeah.
Okay. Well, but it's good to know. Thank you very much for your support, Fernando.
Welcome.
Okay. See you later. Okay, next question. This one is for you, Anaïs. Have you developed the Ocean Viewer software in-house, or can that be forked and reused for another project?
I haven't developed my ocean viewer, but it's Copernicus Marine. But yeah, of course, you can use this interface for your own project with the embedded link as seen previously, and on the introduction of MyOcean viewer article, you have a section with the embedded link, and we explain you how to use this embedded link to have this interface on your project, for example, in Python or in HTML project.
That's right. Yes, so the conclusion is basically a lot of the resources are already explained and in depth in our help center corner. Cedric will tell you a little bit more on how to access that corner in a few minutes. And maybe one last one for you, Anaïs. Is there a limit to the amount of information we can download per day, month, or year, etc. from the, I assume from the viewer, or in general from the Copernicus service?
It's a limit for the download, but we have a limit for download per file. But there is another option to download files. It depends your parameter, your area, also the time range and the depth level. But there are many ways to upload your data, and another limit is the product available on the Copernicus Marine.
Okay. I think maybe we'll have to pass on to our next speaker, and we'll try to answer the rest of your questions after. Thank you a lot, Anaïs.
Thank you.
So now we'll pass to our first use case of the day. Andrea Orihuela Garcia. I'm sorry if I'm not pronouncing your name properly.
It's okay.
Andrea is a PhD student at Barcelona Supercomputing Center, and she has been using Copernicus marine data. She is here to present you with her example, her use case. The floor is yours.
Thank you. Hello, my name is Andrea, and I'm here to talk about how I use Copernicus marine data in my case of study, the distribution of particulate organic carbon in the POC in the mesopelagic layer. So first of all, you will be probably wondering what is actually the particle organic carbon and the POC. Well, the POC is all the carbon in solid format that comes from the organic matter produced at the first ocean level, so from 0 to 100 meters, the epipelagic layer. It includes the carbon from large and small phytoplankton, the carbon from micro and mesozooplankton, and the rest of them. So the small and large detritus. This detritus includes the organism, poo, and the rest from sloppy feeding all along the food web. This carbon that is produced in the epipelagic layer, from 0 to 100 meters, is sinking downwards, affecting to the carbon content of the rest of the layer, the upper mesopelagic layer from 100 to 500 meters, the lower mesopelagic layer from 500 meters to 1,000 meters, and the bathypelagic layer below 1,000 meters. Once you know what is POC, probably you will think, why do we care about it? Okay, so as phytoplankton is capturing the CO2 that was originally in the atmosphere to create its organic matter, it's an ocean mechanism to mitigate the CO2 additional that is driving the climate change. Because once this POC is exported below 100 meters, it will be sequestrated over 10 years. Once this POC is exported over 1,000 meters, it will be sequestrated for 1,000 years, preventing it to be in contact with the atmosphere, so mitigating the climate change in this way. To study the distribution of the total POC, we use PISCES biogeochemical model coupled to NEMO, that is an ocean dynamical model. These models allows us to study the distribution of total POC in all these processes that I was explaining before in 3D in the whole ocean. We evaluate our simulation using the total POC from Siemens, from the multi-observation global biogeochemical 3D product that also includes chlorophyll and backscattering. And it's super useful product because apart from 3D, it is based on ocean color data, Argo floats, and CTD vertical profiles, giving us a global vision of the whole ocean. Our simulations are evaluated by using Python and ESML tool, that is an evaluation tool that is partly developed at the Barcelona Supercomputing Center. To evaluate our total POC from our model in the upper mesopelagic layer, so from 100 meters to 500 meters, we compare the March, April, and May seasonal climatology for these levels. So integrating between these layers. The total POC from our model with the one from Siemens. Overall, what we can see here is that we are underestimating the total POC from Siemens in more than 50%. This could be because our model is strongly biased, but we know also that a POC from Siemens is not a direct observation, but it is an estimation from backscattering from Siemens. There are some other uncertainties in the estimation of total POC, and for example, there are another algorithm that estimate it using backscattering from Siemens also, like for example this one, the one developed by Gali, that is also including the mixed layer depth and the latitude. And we can see here that comparing our model with the total POC computed using this method, we have a better agreement. However, we can see that we still have some bias underestimating the total POC in the Norwegian Sea and overestimating it in the northern and eastern border of the North Atlantic subpolar region. To know from where are coming the bias, as we know that what is happening in the upper mesopelagic layer is related with the surface, we are presenting here the study of in this case, the chlorophyll at the surface, so between 0 and 10 meters. In this way, as we can see here, we have some bias in, for example, the subtropical area in the Norwegian Sea, and also in the northern eastern subpolar North Atlantic. To reduce this bias as much as possible, we are forcing our model to follow the surface phytoplankton carbon biomass observation from ESA. The result of this restoring is that we are correcting overall the surface bias in chlorophyll, as we can see here in the Norwegian Sea, in the northeastern subpolar North Atlantic, and in the subtropical area. To see what is happening after the change in the surface in the upper mesopelagic layer, we are comparing our two models, the default one and the restored one, using the total POC from G22 method, that is the one I explained before. As we can see here, overall, the restoring is having a moderate effect in the total POC in the upper mesopelagic layer, because having a correct total POC at the surface, or having a better estimation of the chlorophyll at surface, it is not translate into a good POC in the upper mesopelagic layer because of the carbon fluxes that are coming from surface to the mesopelagic layer. Those fluxes are also controlled by biochemical processes and physical processes that are related with the distribution of POC. However, even if we didn't reduce the bias globally, there are some regions, like for example, the Greenland, Iceland, and Norwegian Sea, the Aegean Sea, where the restore was reducing the bias, and another bias in where we are, like another region where we are increasing the bias, like for example, the Western Subpolar North Atlantic. In this sense, and taking these two regions in specific, we are showing here the seasonal cycle of the chlorophyll, so between 0 and 10 meters, to see what is happening in this layer. So at the top we have the Aegean Sea, and at the bottom we have the Western Subpolar North Atlantic. And the Aegean Sea, as you can see here, in the left we have the default model, and in the right we have the restore one. The dashed line is the chlorophyll from CMEMS, and the dark line in green is the chlorophyll from our model. The other two lines are the components of the total chlorophyll from our model. In the case of the Aegean Sea, as you can see here, the bias is reduced by diminishing the curve of chlorophyll from diatoms, and by changing the second peak of the chlorophyll from small phytoplankton instead of reducing it as it was doing the default model. On the contrary, in the Western Subpolar North Atlantic, we are not reducing the absolute bias, because we are passing from a positive bias in the default model to a negative one. To see what is how the upper mesopelagic layer is behaving after the change in the surface, we have here the seasonal cycle for these two regions, as the same of on the last slide. We have at the top the Aegean Sea, and at the bottom the Western Subpolar North Atlantic. As we can see here, in the Aegean Sea, the bias is corrected, although we know that there are some bias that we have to fix. But we can see, like for example, the red line, that is the total POC from our model, has a shape more similar to the one from the backscattering from Siemens, so the G22. Well, the other lines here are the components inside the total POC, so they are included in the red line. Secondly, in the Western Subpolar North Atlantic, as we can see here, the bias is increased in this case after the surface restoring, by increasing the small detritus in the orange line here. So what we can get from here is that to study, to have a better understanding of the total POC in the upper mesopelagic layer, it's of key importance to study the behaviors and the change in the distribution also of the small detritus, because thanks to that, even if we didn't correct the whole bias in the upper mesopelagic layer, we can know that thanks to the small detritus, we have a change in the total POC. So in that way, we conclude that Siemens product give us a global vision of key observed variables that are difficult to measure in a continuous way, that despite its limitation, it allows us to evaluate our model, and it enables us to calibrate it in the future, like for example, changing again the different parameters. And also we confirm that changes in the total POC distribution are driven by the sea surface processes and the transformation of living biomass to detritus through the whole water column, and also that these detritus are the main fraction of the mesopelagic total POC. Thanks for your attention, and if you have any questions.
Thank you very much, Andrea. That's always nice to see a practical example on how to use the data, right?
Thank you.
Let's see if we have some questions for you. And just a reminder, everyone, once again, thank you for your questions, and they will be we'll try to answer them as much as we can. On the Padlet, to access the Padlet, we can also share again, maybe, oh yeah, we've just shared it. So you will find on the chat of Zoom, you will find the links to the Padlet, to Slido. Great. So the first question. So some of these questions are not specifically about your work. Maybe it might be more like your recommendation or your suggestion. So what would you recommend if I'm interested doing an ecological study offshore Liberia, specifically in the Atlantic Ocean along the coast of West Africa?
Well, my question is if this question is about the variables that this person should look at or the product. Well, the variables, first of all, I will look into the chlorophyll and also some physical variables like temperature, salinity, and those things. There are for sure products in Copernicus Marine to study that. So yes, they take a view using this viewer that she was presenting before. I think this is a good idea. And using the chlorophyll, for example. For me, the chlorophyll is one of the variables most important to study.
Exactly. I just wanted to say that you on the catalog, once you enter on the catalog, you will be able to select, as Anaïs showed you, pre-select what you would like to see, if it is physical or biochemical variables, etc. Another question, the CSV sample data, how representative is it? Would it be possible in the future to download more than a sample in this way for small areas, single points? So I'm not sure if this is specifically for you, or maybe it could be still for Anaïs. Some of these questions is a bit hard to identify. Maybe we can go. Is there a data set or a way to obtain data on carbon stored or sequestered in the sea? Thank you for your response.
Okay, so the carbon is stored or sequestered in the sea is this is the point. This is why we are using model, because it's really difficult to study the carbon that is already stored in the ocean. So you can see the content of total POC, but maybe if there are products that use CO2 in the different water masses, maybe you can look at that. But to study the observations is super difficult, because this particle organic carbon are influenced by different processes, biochemical and physical. So it's super difficult to have an observation of that. We have sediment traps in, for example, in BATS station and in PAP. I don't know if they are in Copernicus, but there are some data there, but it's not about carbon stored or sequestered. It's carbon, like POC in particle.
Yes, I can just complement by saying that we do have an indicator on the CO2 uptake in the ocean. But yeah, like you said, it is it's again model data. So I think we have answered all of the questions for you for the moment. Yes. Thank you very much, Andrea, once again.
Thank you, you too.
For your presence. And now we're going to give the floor to our next speaker. Who's Luc Vandenbuckle, who's going to talk to you about a second use case. So another example on how to use Copernicus marine data to study ecosystem level environments. So the floor is yours, Luc, whenever you want.
Okay, hi, thank you.
Just sorry, I didn't introduce you properly. Luc, you have a small company, right? Jailoo SRL. I'm not sure if this is the one. Yeah, okay. Based in Romania, and voila, the floor is yours.
Okay, thank you very much. I would like to present to you two different aspects of the way in which we can assess the state of the ecosystem. And as an example, I will talk about the Black Sea, because that's my area where I'm working. So the first part is concerning the long-term changes to the ecosystem, and the second part will be about the very short-term present state and forecast. So just to give you a little bit of context, the Black Sea is a sea which is having a huge drainage area. So there's a lot of river water coming into the sea, coming from a large part of Europe and also the area to the north, so Russia and Ukraine. And during the last decade, so from the 50s to the 90s, there was a huge increase in nutrients in the fresh water from the rivers. So some estimates say that there was 10 times more nutrients than before the industrial times, mostly due to fertilizers in the agriculture. So the fact that so many nutrients came into the sea leads to eutrophication, which is defined as the over presence or too many nutrients in the sea. And this leads to a huge development of phytoplankton. And later on, when the plankton dies and starts to sink to the bottom, it is degraded at the bottom of the sea, and there it consumes all the oxygen, and this leads in turn to something called hypoxia, which is the fact that there is no more sufficient oxygen on the bottom of the sea. And it leads to the displacement or the death of the animals living on the seafloor. So after the end of these decades and starting from the years 2000, there was a partial recovery from eutrophication because in the European drainage area, so the Danube River mostly, some laws were implemented by the different governments of the different countries to try and limit the nutrients in the agriculture. It's not really the case for the rivers coming from the north, so from Russia and Ukraine. So that's why we say it's a partial recovery. But then later on, due to warming, the cold waters start to disappear. The water is starting to get warmer. And again, this can lead to hypoxia. Of course, if the water is warmer, then less oxygen can be dissolved in it. So the question now is, can we assess quantitatively with some numbers how severe this problem was in the past and in the present, and how is the system evolving? Are there some products in the catalog that we can download and look at to answer to this question? And the answer of course is yes. First, I would like to show you briefly something about a physical variable. So in the Black Sea, there's a layer of cold water below the surface, and this layer is a barrier preventing vertical transport of different biogeochemical components. And if this layer disappears, then the whole ecosystem will change because the vertical fluxes will be modified. So to look at this barrier, its presence or absence, we download the temperature product from the CMEMS catalog in the Black Sea, and then we look at how much cold water there is. So on my graph on the right side, the higher the bars, then it means there's more cold water, or the water in the cold layer is even colder. So you can see in the 80s and the 90s, there was a lot of cold water, and then it starts to decrease slowly. And in the last years, we have some years where there's no more cold water at all. So in these last years, you don't have any barrier anymore preventing the exchanges between the surface and the lower layers. So it's already clear that something probably will change in the biogeochemical state of the sea. Now going to the biogeochemical variables themselves, if we want to look at this eutrophication problem and its potential recovery, one way to do it is look at the total chlorophyll content, exactly as was mentioned in the previous presentation. Chlorophyll is a very, very powerful indicator. And indeed, we can see that from the 80s, there was an increase in the total chlorophyll content in the sea. And then after starting from the second half of the 90s, there's a decrease. So we can see that there's a little bit less chlorophyll. I forgot to mention that the blue curve is the chlorophyll in the deep sea, whereas the red one is the one close to the coast, on the shelves close to the coast. But the Black Sea has a very, very large shelf, so it's really important. And this is also where all the river water is coming into the sea. So indeed, we can quantify the eutrophication. We can see that there was an increase in chlorophyll content and then a decrease. And then we can also see that in recent years, there seems to be a small trend to increase again. Another thing that we can also deduce from data we download from Copernicus is the hypoxia. So hypoxia is the is a word indicating if there's a lack of oxygen in the water, and the bottom hypoxia is the lack of oxygen above the sea floor, on the lowest layer of the sea. And we can download the oxygen variable from the Copernicus catalog, and then we look at the surface, how many square kilometers are affected by oxygen, for example, smaller than 60 micromoles per cubic meter of water. And this extent is the area where animals, for example, so animal life on the bottom of the sea, on the seafloor, is probably going to die, or at least to be displaced. And we can indeed again see that during the 80s, there was an increase of the area affected by hypoxia, and then there's some kind of recovery. And then in the recent years, we can see that there's probably again an increase in the surface of hypoxia. So unfortunately, in the early 2000s, when people started to notice this recovery, thanks to regulation of the agriculture, etc., people were very, very optimistic that there would be a recovery, and maybe a full recovery, which would show us a trend towards zero here, no more square kilometers affected by a lack of oxygen. But unfortunately, the data shows us this was not the case. Hypoxia is still a problem, and is probably even becoming more severe again. So these were some 3 examples, one with data from the physical, some from the blue ocean, and 2 from the green ocean. But there are other things that we compute as well. And on top of that, there are also things that you can download on the CMEMS website, which are called Ocean Monitoring Indicators, or OMIs, were mentioned before by Razvan. And there are some indicators pre-computed for you, so you can see in the catalog something about the state of the sea. So, for example, hypoxia in the Black Sea, it's already computed in the catalog, and you can download directly the indicators. Also, the surface chlorophyll is also in the catalog, and this one is based on not on models as the ones I showed you before, but on satellite imagery. So it's only available after 1997. There's a new indicator, which is the total chlorophyll, so not only the one on the surface, but also in depth, which is foreseen for the Black Sea, and it will become available in 2024. And then, apart from the existing ocean monitoring indicators, it's always possible, if you're interested, to compute other indicators yourself by going back to the raw data, the original data. You download them, you process them, you integrate over the basin, or you integrate over the vertical, or you compute some diagnostics which are interesting for your own case. And for example, in the case of the Black Sea, it's very interesting to look at the depth of the deep chlorophyll maximum, at the depth of the oxycline, so the depth at which the oxygen is disappearing, etc. So the answer to my first big question, can we assess quantitatively the state of the ecosystem, in my case of the Black Sea, using Copernicus products? The answer is a clear yes. Some of the indicators are pre-computed and are just there for you to download. The other ones require you to do some processing or some computation of some diagnostics. But in any case, it's possible to clearly assess the state of the ecosystem. The second part of my talk, I want to say something more about the very short term. So the past few days and the next few days. So starting from tomorrow, and for example, the 5 next days, or the 10 next days. And in this case, I want to speak as what CMEMS calls an intermediate user. So it's a user which downloads or uses products from CMEMS to create another product or another service that will be in turn used by the final user. And the final user in this case would be a fisher, or maybe somebody who does aquaculture, so has some farms and is trying to raise some mussels or some fish on the shelf, so in the coastal area. And this particular example that I want to show you is coming from the Four Coast project. So this was a European research project aimed at providing services to fisheries and aquaculture. And so there were many partners in the project which developed different pilots all around Europe. And my own particular case, done together in collaboration with the National Institute for Marine Research from Romania and the University from Belgium. So all together, we developed a coastal forecasting system. And this system is using Copernicus CMEMS data at its boundaries, because you cannot run a coastal system independently at its open boundaries towards the sea. You need to have some data to force the coastal system. And this data is coming from CMEMS. And in our case, the model is covering the Romanian coastal area, and it simulates the blue and the green ocean, so the physics and the biogeochemistry. And apart from doing the models, the different partners in the Four Coast project also developed tools which are useful to fishers and to aquaculture. And I will present to you now the model we developed and some of these tools. So here you can see on the left side, you can see a high resolution model just of the northwestern shelf in the Black Sea. And then this model takes boundary conditions from the CMEMS models on its open boundary to the south and to the east. And then inside of this area, we have another area located here at an even higher resolution. So now we can start to see really the details of the portal structures and of the coastline with everything, with the little islands and everything that you can find in this area. And so we ran the models in these two grids, and the model results are put online on a server. And then there are some services which use the forecast and the results to provide some services to fishers and to aquaculture. And in the particular case of Romania, there was a question where some people are trying to run an aquaculture farm. So they're trying to raise something in this orange box here in this area of the sea. But their problem is that there's a city here, and this city has a water treatment plant for the wastewater of the population of the city. And sometimes it could happen that the wastewater plant doesn't have the capacity to treat all the water, and then the excess wastewater is discharged in this point. And the question for the aquaculture is now if the wastewater overflow will reach their farm. So we set up a service, and we use the currents from the models, and we compute if there was a discharge here with potentially bacteria in it, then will they or will they not reach the farm. And the final product that we can propose to the people doing aquaculture is something is just a simple alert. So if a certain threshold, if a certain quantity of this potential pollutant release here reaches their farm here, then they are going to get an alert. Maybe it will come on their phone, or maybe they connect to the site, or by any means that they desire. And we can also give them more information. For example, we can tell them how old the pollutants are. So if the pollutant took 5 days to go from the wastewater overflow discharge point to their farm, then probably the bacteria are already dead because they can't resist in salty water. And so the problem is not really a problem. If the particles come very quickly in a single day, then it's really important for them to know this. So this was one service that we proposed to aquaculture, but other partners in the project developed a lot of other services. Some of them use data from the blue ocean, others from the green ocean. And one of these services concerns, again, aquaculture. Now, the question that the people would be asking would be, what is the best site in my area to build a new farm? So there's certain thresholds or certain variables need to be in between limits for the farm to be able to function. For example, if they are close to a river, then the salinity could drop towards too fresh water. So they need to know, is the salinity high enough, etc. They need to know if there's enough oxygen in the water. They need to know that the temperature is right, so it can be either too cold or too hot. They need to know that there's chlorophyll, because this is very important for them for an economic point of view. They have to feed, for example, if they are going to raise mussels, they have to feed them, and the quantity of food that they are throwing to the water depends on how much food there is already naturally in the water. So if there's a lot of phytoplankton, maybe it will be economically more viable for them. And all these information, they can obtain from CMEMS, but it's maybe difficult for them to obtain it. So this is why the Four Coast project try to provide an intermediate service for making this data accessible for them. Another service was targeted at fishers. So it's well known that fish tend to live in the area which are called fronts, which are areas between different water masses of different temperature or different biogeochemical state. For example, one water mass with a lot of chlorophyll, another water mass with very little chlorophyll. So the idea here is to use again the models to detect these fronts and indicate to fishers where is the optimal place to go and start fishing. And you have an example on the right where you have very strong fronts between different water masses painted in red, and weaker fronts, so maybe a little less probability to find a lot of fish in yellow. Anyway, if you're a fisher, you're it's probably a good idea to go to one of these red lines or maybe one of the yellow ones if you don't want to go to the red ones, and it could potentially save fuel and time and effort if you go there to fish. Another service is just aimed at providing quickly the environmental status to people doing aquaculture, for example, by providing them conditions on temperature, salinity, oxygen, acidity of the water, chlorophyll, the presence or not of bacteria, and all kinds of different information which conditions the day-to-day work. So these are really very short-term bulletins that are sent to the managers of these companies and help them do their day-to-day operations. And the lead time which we can provide is depending on the lead time of the CMM's products. So usually now it's 10 days for most areas. And that concludes my talk. Thank you very much.
Thank you very much, Luke, for your presentation. That was very complete. So some of these questions might be, sometimes they are very broad, so not so specific on your use case. If you're not able to answer them, it's okay. We'll read them anyway. So this might be someone interested in using chlorophyll as a variable. Is it possible to separate the biomass of plankton from macrophytes? For example, seagrass and seaweed in assessment.
Actually, it's a trick question for me, because I think in the models that we use to provide the forecasts, or also the long time series in the past, we don't simulate the seagrass or seaweed. So all the chlorophyll is only the plankton.
So I think this question, I'm not sure if it is still for Andrea or if it is for you. Did you extract the data using a Python API or QGIS? Also, is there a way to estimate how accurate the Copernicus data is for assessing the TPOC levels? Does this make any sense to you, or is maybe a question for Andrea?
Giving the last part of the question, she's
POC
talking
levels.
about POC, so it's probably not for me.
Okay, Andrea, if you're there and if you want to answer.
Okay,
I can. We read it.
I didn't extract the data using QGIS. So the data from total POC from backscattering from CMMs is already in the West. You can download it, and you can download also the total POC from there. To estimate how accurate the Copernicus data is for assessing the total POC levels, I think that there should be a lot of ways to know if it is accurate or not. That what I do is evaluating the different data that I have and reading the documentation of both things.
Thank you. You're still around. You can still jump in.
Maybe we can add something as well. So
Yes.
In general, not for POC in particular, but in general for all the products in the CMM's catalog, you always have this what they call the QID, so this quality information document, where you can find statistics about the expected error of the different products that we're downloading or looking at.
And also, particularly in the product that I am using, the multi-observation biogeochemical 3D, they have also one variable that is POC error. So you can see there the uncertainty that is related with the algorithm that they use to compute POC from backscattering. And also you have the error with chlorophyll and the error of the backscattering. So in the same file, you can find that.
And if you're interested in errors for the very recent products, so the near real-time forecasts, then they have what is called the product quality dashboard, where you can find the statistics for the last months. So the error statistics of very recent forecasts.
For your answers. Great. So maybe I'll skip this first one. Is there? Yeah. Okay. So this one. I wish to study the positive impacts of mangroves for ocean health and climate resilience. What parameters and data sets should I explore other than temperature? Okay, maybe this is also not specifically for you, Luke. I don't know if you want to answer or... we can also.
I'm sorry, I don't
take a bit-
really know
Yeah,
much
no,
about
it's not.
macros
It's a bit more
specifically.
general. Next one, there is a possibility to see the effect of temperature on mortality in aquaculture cages in a single point. Also, maybe out of your range, I'm afraid, or
I think
I don't know.
it's a good question. So actually there is an effect of temperature on mortality, and I don't know what you mean by in a single point. So you would have to extract from the Siemens catalog the temperature in this particular water column, and the people doing aquaculture actually lower or raise the cages as a function of the environmental characteristics that I showed before. So they take this into account, and they know the temperatures of where it's becoming dangerous, and then if it's, for example, if the surface is heating a lot, they will put the cages lower.
Now this one seems to be specific for you. Why chlorophyll is higher on deeper waters of the Black Sea rather than in the shelf waters influenced by nutrient
the graphic I showed before is the total chlorophyll. So actually the chlorophyll concentration is much higher on the shelf where the river is flowing, but the total area of the deep sea being much larger, there is more chlorophyll in the deep sea, but just because it's a larger area. The concentration is much higher close to the river. So sorry if this wasn't clear during the presentation.
So is it possible to upload information post-model predictions in your fisheries? Fisheries example, if fishermen go to the areas and don't find fish, for example.
So this is probably a question for CMEMS or for Fernando. So I guess from my point of view, I would be very interested to have this feedback. But I don't know if technically this is possible for CMEMS.
Yes, I think we are not yet able to have this interaction yet, but this is indeed very interesting. And like Fernando said, we are interested in having more and more data. The more we can, the best. Okay, thanks. Last one. Have the CMEMS products in the PS catalog too low resolution for direct use for the ecosystem assessments you showed?
It depends which kind of assessments you want to make. So if you're looking at hypoxia or the long-term assessments that I showed in the beginning, then I think the Black Sea product is quite okay. The resolution now is 2.5 or 3 kilometers. So it's quite okay. If you want to do very specific forecasts, like very short-term forecasts for aquaculture, etc., then you probably need a coastal model.
Thank you very much, Luke, for being here, for answering all these questions, and we'll give the floor to our next speaker.
Thank you.
Thank you. Cedric Giordan is a user support manager at Mercator Ocean International, and he's gonna he's gonna be our last speaker of the day, and he's gonna show you how to access the help center, how to access the website and the user corner. So the floor is yours, Cedric.
Hello, good morning, everybody. And so I'm Cedric from Mercator Ocean International, and so I manage the user support team of the Copernicus Marine Service. I will give you a short presentation of the user corner. It's an area dedicated to users, and you will find inside several useful information to make the best use of the data and the services. So to reach the user corner from the main page, there is a direct link in the menu here. So you will find different boxes. The first one, getting started. So this page is under improvement. So if I click this link, you will find a sum up of the offer, and below an operational path to follow to learn, in fact, how to use services of the Copernicus Marine Service. So you can always you as well find a getting started section in the help center. So this section is very, very important one. So I follow the link. Here in the help center, you will find many articles that are sorted by collection and specifically introduction to the Copernicus Marine Service. If I click on this one, I reach several subsections and articles. and getting started, what type of content does Copernicus Marine Service provide, etc. So I click on the title and I reach the article with the theme table, and you can browse, and you will find videos, links, pictures, etc. So everything is in the epicenter, and it is really an important section and really useful. So do not hesitate to check it. You can specify a keyword, for example, inform. You can, for example, I can read this article, how to be informed of operational events on products and services. I will I will show you later the specific page to have the list of these operational events. So I click on the title, and I reach the article, of course, and you will see how to reach the section and how to build a RSS feed to be informed automatically on operational events. So I will show you later this section. So I come back to the user corner. So this is the section I referred before. In this one, you will find all the operational events regarding the products and the services. There are 4 different sections. So general, improvement, incident, and maintenance. And for each section, you can build your own RSS feed using these the filters available. So if I'm interested in global ocean events, I sort global ocean, and I can make this view as an RSS feed, and then in the article here, it will be explained how to receive automatic email or to have automatic posts and on your browser, etc., to be informed of when there is an incident on a specific product. If I click on the title of the notification, I have here the name of the product impacted and the status of the incidents. So this one is in progress, so is under investigation, and it will be fixed soon. So I come back to the user corner. The next box is about the user learning service. Here you will find all information about the training and workshops. So next, the future events or past events. You can see the current one. And linked to this section, you will have the e-learning materials. In this one, you can find 100 resources, more or less, with the notebooks, Python scripts, etc. You can sort on the level subject tool here. For example, I went Python, and you will reach different resources depending on the level. And so these resources are useful to train, in fact, on the Copernicus Marine Service. So the resources shared during the training are posted in this section. Sorry. I come back to the user corner. The next one is the product quality. In this embedded website, you will find generic information of the quality of the different parameters of the Copernicus Marine Service. There are 3 different categories, so blue ocean, green ocean, and white ocean, depending on the type of variable, and as well different sections on the area. So I'll let you discover this website, and you will find useful information on the quality of the products. I come back to the user corner. The product roadmap. So here you will find midterm planned improvements. So to have short-term improvements, you have the specific section of the user notification service called improvements. And in this one, so this one is being improved as well. And you will find here midterm information on the products and the service. So I click, for example, on the section, I have improvement the type of improvement. So this one is improvement quality control procedure for oxygen data for the 7 in-situ regional products. So as I said before, this section is being improved. So that's why the last date available is November 2022. So it's not midterm because it's the past. So this page is being improved. The next box is Get Inspired. So here you will find all the use cases, the example of application with our data as presented before by Luke and Andrea. So you can sort by region, country, market, one of the 12 blue markets, and you click on the icon and you have a description of the application, the product used, and useful links on the application. So do not hesitate to check this page to have several examples of application. And when you after using data and services and after building your own application, you can submit here your use case, and so your example, the specific example, will appear on this page. The next box is to log in and register. So you have to register to download data and to send us a message using the chat. You can use a specific. I will show you later. You can use specific form to contact us, but if you want to contact us through the chat, you have to be registered. It's important to note that the registration is completely free and the use of the data is free as well. So it's pretty useful to be registered. So the registration is fast. You will receive an automatic email to validate your email address, and you will receive automatically your login password to connect to log into the website. Service commitment and license. Inside, it's more a legal document to give details on our commitments, the time to answer to your question, to fix incidents, etc. So I'll let you discover this document. And the last one is the contact us. If I click on this one, you reach a specific form to fill in and to contact us. When you submit it, you will be automatically informed. And as well, you can, of course, contact us using the chat at the bottom right of the screen. Here, I click on the icon. Here, you have useful articles. You have as well a direct link here to the Help Center with the collection and the same possibility to type a keyword to find your article. You will find an history of your messages, your exchanges with the user support. And so here you can send us a message, of course, and you will reach Anaïs, you've seen before, or David, or another member of the team. So do not hesitate to contact us. And as said before, do not hesitate to check the Help Center, because it is really, really a useful resource. So many thanks for your attention, and bon appétit.
Thank you, Cedric. So we hope now you got a full overview of how to access the Copernicus Marine Service, how to access its data, how to visualize it, and hopefully tomorrow you will get a more insight on how to process the data. So as Cedric showed, you can, if you have any questions more related to data or to how to access the data and the products, please go ahead, contact the Help Center. Cedric already showed you, and I've shared on the comments as well, the link for the Help Center box. Thank you. And so we are about to conclude today's session. Before we finish, we just would like to share slide one last time. I think we don't have any questions for you, Cedric. Thank you. We just would like to share the poll where you would be able to respond some questions related to today's session. So it's a survey that will help us a lot to improve next sessions. And it would be really nice if you could spend a few minutes just filling in these responses. If you go to Slido, you will be able to fill it in. Julia, if you click on the green button, you launch the poll? Yes. Okay. And then for the participants, you are able to respond to this poll at the same time, to this survey. Thank you very much. That will help us a lot. And at the same time, maybe if Julia, you stop sharing your screen, because I would like to give more information about tomorrow's session. Thank you. So for tomorrow's session, tomorrow, as I said, we will have a practical session. Today was an introductory session to the Copernicus Marine Service. Tomorrow you will have hands-on the data and how to visualize it and process it in Python and in QGIS. Tomorrow we will have Stefania Ciliberti and Alvaro de Pascual Colar from NoLogin, who are going to demonstrate two very interesting tutorials related to this topic. So it will be a 3-hour long webinar. So if you're interested to come and practice with us, that will be very nice to have you. Now I think we can conclude our session of today. If everyone, all the speakers would like to turn on your camera just to say goodbye to our participants. Thank you all. Thank you everyone, all the speakers who are here today with us, Andrea, Luke, Razvan, Anaïs, Cedric, and Fernando also for jumping in. And
Thank you.
Thank you everyone. And thank you all for your questions, and have a good day.
Have a
See you
good day.
tomorrow.
Thank you. See you.
Bye.
Bye-bye.